All right, let's get started. We've got quite a few people on board the webinar and some more coming in, so let's go ahead and get going. So I'm Chris Barnett with Barnett Strategies, and I'm here to host a terrific webinar today with my friends Andrew Poliak from Panasonic Automotive and Jeff Rogers from Sensory. So welcome everybody. And today, as you know, our topic is driving innovation, Sensory and Panasonic Automotive's hands-free future. So today we're going to explore Sensory's truly hands-free solution and its impact. And there's going to be a demo of Panasonic Automotive's hands-free trunk open and close feature that's powered by Sensory technology. So let's get into it. I'm going to do a quick intro of today's speakers, and then we're going to get into their material and a good discussion. And again, I'm going to remind everybody attending, if you'd like to post any questions, you'll see a Q&A button at the bottom of your interface there, and you can post questions. So welcome, Andrew. Andrew Poliak is the Chief Technology Officer for Panasonic Automotive Systems of America, and as CTO, Andrew leads innovation initiatives, includes advanced engineering, advanced user experience and UI vision, and also product planning, and leads business development with major automotive mobility customers. So, Andrew, welcome.
Thank you. Thank you for having me.
And also we have my friend Jeff Rogers, who's been involved in influential in the development and design of hundreds of products over the last 29 years that use speech and computer vision technology. Just focus on how to implement Sensory's technologies into real-world products has played an important role in Sensory's success in the market. And Jeff has licensed speech and computer vision tech to companies like Amazon, Google, Honda, Lenovo, Microsoft, of course, Panasonic Automotive, Samsung, Zoom, and many more. So Jeff, it's great to have you here today.
Thanks, Chris. It's great to be here with you and Andrew. Thank you.
All right. So Jeff is going to kick us off with an intro about Sensory. Jeff, I'll hand it off to you.
Thank you. Good morning, good afternoon, and good evening to all that are attending. Thanks for joining our webinar today. Really exciting things that we're going to show you today, both from the perspective of our Truly Hands-Free, which is really well known, as well as later in the webinar, I'm going to introduce our complete new automotive solution that runs completely in vehicle as well. So, and I've got some live demos that I'll do. Live demos are always really interesting and scary because, you know, it's a live demo, so things can go wrong. But, you know, our tech's really good, so I'm excited to show it to you, and I'm sure it's going to work out great. So pretty excited for this with this webinar with Panasonic. Panasonic's been a great partner of ours for many years. We work closely with Andrew and team in the US as well as with the Japan office. And again, just a great partner. So just a quick intro on Sensory. We are definitely leaders in on-device AI technologies. We have a full voice and vision technology suite designed for automotive. We're certainly known for wake words. We've done a lot of wake words. But we also have now speech to text that runs completely in car. And again, later in the webinar, I'll show some demos of this. It's really cool. Voice and sound ID. So our sound ID is also being designed into automotive right now for things like emergency vehicle detect. And then we can also do things like recognize baby cry and dog bark in case you forget something in the back seat or glass break. We also have face ID and behavioral recognition. So we're using our computer vision for things like drowsy, detecting drowsy drivers or gaze detection to see where people are looking, kind of thing. On the voice side of things, we can not only recognize that a wake word was said or that the speech was said, open the sunroof as an example, but then identify who said that. So combining all these technologies together makes it really interesting. Always on, always available. Everything that we're going to talk about today runs entirely in vehicle. There's no need to rely on network connections, which can be sketchy. And so again, always on, always available. Complete data privacy and control. The data never leaves the vehicle. Really flexible and efficient edge AI performance. We can run on the CPU, we can run on the GPU, we can run deeply embedded. I've seen some solutions lately that talk about, hey, if we put this really powerful GPU in here, we can run speech solutions. Well, those are expensive, and there's a lot of drawbacks to them other than the expense of those. And everything I'm going to show you today can run on the CPU, which is pretty exciting. Lowest cost of ownership. There's no cloud infrastructure. Anytime you go to the cloud, there's cost, and everything we're going to show and do today runs on device. And obviously, market proven, lots of languages and different solutions that are available. Sensory has been in business now over 25 years. We've licensed over 200 large companies with more than 3 billion products that have shipped. and in every major country in the world. So the logos that you see on the right side there, these are all customers of Sensory that have done real products. And you can see a variety of different markets that are represented there, from automotive to consumer to medical, and then others as well. We've really focused on technologies that work in real world conditions. So, not something that's, okay, this is going to work great in the lab where we use special testing and special specific WAV files to do the testing. No. This has to work in the real market and in the vehicle. So we've got built-in noise immunity to our Truly hands-free technologies that you'll see here in a minute. We also work with third-party noise tech, which become very important for things like AEC to cancel out the noise that the radio might be making, as for example. But as far as, again, working in the real-world environment, this is where it's really key. And the usage that Panasonic has come up with and the demo that you're going to see, you'll definitely understand where that's important. It's good stuff. We've got a full set of tools and test labs and data and all sorts of unique IP that we provide to our partners like Panasonic. Historically, we focused on consumer products, but in the last couple of years, we've really shifted our focus to automotive. And we did that for a few reasons. One is speech recognition in automotive historically has had issues, and we knew that we could provide a better solution. Secondly, we wanted to develop a technology that could run entirely in vehicle, so I don't have the issues of, well, this works great as long as I'm in a really good connection. And then third, we have a lot of different technologies, and we thought, if we combine all these together into a complete solution, this is going to make it easier for tier ones and OEMs to design in, and we've seen that success already. Honda's already shipping cars with our technology. There's another large Japanese OEM that is shipping vehicles this year, and a very large European OEM that will be shipping vehicles next year based on Sensory. So there's a lot going on here, a lot to offer, and excited to again partner with Panasonic. So let me turn it over to Andrew for a quick intro to Panasonic.
Thank you. Let me share. Hi, well, thank you for having me from the Sensory side. It's always been a pleasure to work with you all. I'll give a quick overview of Panasonic, and then we'll get into what we're going to talk about today. So many of you have known the Panasonic brand. It's been around for over 100 years. We celebrated our 100th anniversary in 2018. So, and some of our customers in automotive, we have a regularly updating tech event with one of our customers that we increment the event name each year by one, right? And we're on the 71st episode of that tech event we've done with this particular automotive company. So long history in a lot of different markets and categories, but in automotive in particular, quite strong and quite long. So we're part of a larger holding corporation that's a $66 billion company made up of over 500 different consolidation companies. So quite a large group that is Panasonic, and within that, we're specifically in the automotive company. So I'll give a quick overview. Really where we focus on in automotive is providing comfort for people, a sense of security and safety, and then also focusing on what we can do to enhance the environment, both the living environment inside the space you're in, but also the environment of the planet we all share together. So in that comfort category, it really extends to a lot of different technologies, but also making things easier to operate in the vehicle. And we'll talk about that a little bit of what we're here to discuss and where we use Sensory pretty extensively. From a customer portfolio within the automotive group, you can see the logos on here. We've worked with pretty much every major car OEM globally and continue to have quite a large success in a lot of different electronics. Our kind of core competency has been on the infotainment and the cabin space, but we've went from a non-player in the head-up display market to now the dominating supplier, tier one supplier within HUD, audio systems and branded audio systems, cameras, sensors, all kinds of different devices that we ship within these different vehicles. And as I mentioned on the infotainment side, we're definitely the dominant infotainment tier one globally, where you can kind of see the market share we have as of 2023. So in the Automotive Systems Company of America, which I'm the CTO of, so we're broken out regionally, where PASA, as we call ourselves, is the Panasonic Automotive Systems Company of America. We're headquartered where I am here in Peachtree City, Georgia. It was founded, the American entity was founded in 2003, and we had a manufacturing facility, and then have grown to have teams in Texas, California, Michigan, and here, but headquartered here. And we have about 920 employees in the US and total of about almost 6,500 in North America. And just out of our automotive company here in the US, we're about $2 billion in sales. But, you know, we're the largest and fastest growing business within Panasonic North America. So as I mentioned, we're made up of over 500 companies globally, but we're definitely one of the largest growing, especially here in PASA. So that's kind of a quick overview of where we are. I'll stop for a moment and then we can talk a little bit about the solution we came up with. Oh, you're on mute.
Okay, thanks, Andrew. Let me share my screen again. By the way, for those that have never been to Peachtree City where Andrew is, it's a really cool city. It's like this planned community. They have all these golf cart trails that go all over the place, and you drive your golf carts from stores and school and whatnot. I don't know, Andrew, if you've got a golf cart, but I think it's a really cool area.
Yeah, first two questions they ask you when you move in. I won't say both of them, but the first one is definitely, do you have a golf cart yet? We are under a tornado warning, and it's very dark and stormy at the moment, but so far it seems to be passing, so I think we're all good.
Okay, good. We'll be safe. Thank you. So I wanted to take just a couple minutes to talk about our Truly Hands-Free. We're definitely known for Truly Hands-Free, and Truly Hands-Free is already used in automotive. I just want to go through a couple of points there, and then also show you just quickly a tool that a lot of companies are using for prototype and development that we call Voice Hub. So Truly Hands-Free for automotive. If I start over on the left side, custom wake words, vehicle specific, OEM specific. What we're seeing right now in automotive is, it used to be that you had one wake word and that the OEM kind of had to pick, okay, am I going to connect to Siri? Am I going to connect to Google? Am I going to connect to Amazon? And what we're seeing now, and what's happening right now, is that OEMs that we're working with are running multiple wake words at the same time. And Sensory is being used as the arbitrator to decide where the audio goes past the wake word. So there's a vehicle specific wake word, and so if I say, hey car as an example, and everything that I say beyond that is for car control types of things. Open the sunroof and turn on the seat warmers, and set the temperature to whatever. So that can all be controlled by that specific wake word. Then they still want to be able to connect to Siri and connect to Google and connect to Amazon as an example. And so with our Truly Hands-Free that's designed to run deeply embedded, where we can run very small MIPS in memory, we can run multiple wake words at the same time. And because we developed those as a set of wake words running at the same time, there will never be a situation where Siri and Alexa, as an example, fire off at the same time, because we're arbitrating, and we'll only allow one to go through at a time. So we're definitely seeing that right now in cars, and I think it's something that will expand with more of the vehicle specific types of things, where the OEMs want to own and control their brand, and I get that they should. Don't give it away to Google and Amazon and Apple. And so having a custom wake word that's specific to either the OEM or specific to the vehicle, I think is going to continue to grow. So connecting to the cloud, guys, Apple has their enhanced Siri. It's one of the most challenging wake words out there. It's just Siri. It's not Hey Siri. So it's 2 syllables. There's no good hard sounds in it. It's very, very challenging. To meet the Siri certification, there are 6 tests that you have to pass. And those tests continue to change every time. So there's no cheating where you can just develop to the test, which is kind of what happened with, I think, some of the Alexa IoT stuff, which I think is great. But it means that you really have to have a really solid solution to do that. And Sensory meets and exceeds that requirement. We're proven in more than a dozen languages today with Siri already. So that's really important and good. Alexa certified, we meet and exceed the Amazon automotive requirements. Amazon actually used to be a licensor of sensory technology as well for some of their other products. So we work closely with Amazon. Noise robust, as I mentioned earlier, it performs great both in and outside a vehicle. And for the concept and the product that Andrew's going to show here in a minute, you'll understand why that's really important. And again, we've been designed into many types of products that work and require high noise types of performance, such as sports cameras and others. And so this is definitely something that we're known for. Phrase spotted commands. So Truly Hands-Free also includes what we call phrase spotted commands, where I've got a simple command set and I want to be able to just say that command. And without spinning up the application processor, the CPU, or other things, things like, answer call and ignore call, I think would be good examples of what we could do there. Mentioned earlier, definitely proven in billions of products, so we can check that mark. 40 plus languages and markets, we can check that. And again, deeply embedded as well as application processor. Okay, so Truly Hands-Free development. There's two options, as I mentioned. We've got this really cool tool that's called Voice Hub. And in fact, we're close to releasing our next version of that that will have a lot of improvements and other that are going to be really interesting. But right now we've got Voice Hub. It's all based on synthetic data. So there's no recording, there's no tuning, there's no sensory touch or development on it. And so it's great for prototyping and proof of concept. We do have a few customers that have used Voice Hub models for actually production products. And then we can also hand tune a model. And hand tune is where our linguists, our team of linguists, hand tune down to the phoneme level, the different parts of speech. The development process is an iterative process where we test and tune. And so we start with what is the wake word or what are the commands? And then we add various types of noise files, wind, babble noise, wind noise, speech, car noise, other types of things. And we tune at each step when we're hand tuning a model. I list here operating points flexibility is key. So there's no such thing as one size fits all when it comes to speech technologies. And so what we've done, particularly for wake words and phrase spotted commands, is we have basically a list of operating points that are available to the developer, where there's a balance between false accept and false reject. So on the one end, you'll have no false accepts. On the other, you have no false rejects. And of course, you always look for a balance between those. So when we develop a model, or when Voice Hub develop models, it will come out and recommend a recommended operating point. So between 1, which is very low false accept, and 21, which is very low false reject, we might say, okay, we recommend operating point 8 based on your audio path and other, the other things that you're doing in the car or the way that you're using the technology. But that's just a recommended point. And so the developer can then, if testing operating point 8, they say, oh, we're still seeing too many false accepts, but our false rejects are really low. We say, great, go down to 6 or 5 or 6 or 4 or 3. And the lower you go, that lower that's going to be. But it could also increase false rejects. So again, there's that trade-off. But that flexibility is really important to developers. And it's a similar process for wake words and phrase spotted commands, where again, there's going to be that operating point, and you can adjust between those. So I wanted to pop out of this really quickly and show you an example of Voice Hub. So here on my screen is Voice Hub, and you can see that I can create a new project, whether it's a Truly Hands-Free wake word or a Truly Hands-Free simple commands or our Truly Natural grammar technology. This is the larger vocabulary grammar base, which is different from the speech to text that I'll show you here in just a minute. So if I do commands as an example, then I can go in and I can name it whatever I want to name it. I pick the Sensory SDK version. I choose the language. You'll notice there's a lot of languages that are already included in Voice Hub. English as an example, we've got Australian English, Indian English, UK English, US English, US English Kids. These are all different versions of English. And then we have similar for French and Mandarin, Spanish and Portuguese as well. But a lot of languages are already here. Then I can use this tool to create a custom wake word, and I've done that in a project, so I can pull that in. And then I choose the size that I want as well. So it can be as small as 80 kilobytes and as large as over 7 megabytes. And so in this case, I'm going to use a 1 megabyte model. Then I choose the output format that I want. In this case, I'm just going to use our standard Truly Hands-Free, Truly Natural format. But there's a lot of different platforms that are supported. Like the new ARM Cortex M55, M85 with the U55 as an example, as well as more generic types of things. Like here's the ARM M series, which can be the M4, the M7, the M33, etc., as well as some custom ones. Those I pick the format that I want, and then I just type in commands like make a call or listen to music, show the map, whatever. I just type these in. Then once I'm done with my set, I come down here and I hit build. And a command set can take a couple hours because again, it's using that synthetic data and it's building a model that's balanced between false accept and false reject and is yet still spotted. So rather than take the time, here's the same project and where I've already created the set. So you can see I've entered in these commands here that I just, for the demo, I thought would be kind of interesting. And I've already built that. So then I can test it right here on my PC, or I like to test it on a mobile device that I can then take into the car as an example. So whether it's Android or iOS, it doesn't matter. We support both. So I can download the model, and then using an app that we have that comes with this. So what you're seeing on my screen here is this. I'm just screen sharing my phone here. And so what I can do is I can say, okay, I want to download the model. And so I'll do that. That pops up this QR code. And so then I just scan the QR code here. So did that, and it loads it in. And now I've got my command set that I created here along with this wake word, and it's always on, always listening. So now, I mean, if I'm testing it, I can say, Voice Genie, make a call. And it's great. You can see it, recognize it down here. But that's not how people speak. People are going to say, Voice Genie, I want to make a call right now. And you can see it's still spotted, even though I said all that other stuff before it. Or Voice Genie, podcast. So even though I said the it still got it. Or Voice Genie, I want to listen to music right now. So it's just that phrase spotting capability gives it that natural language fill. And it also means that in high noise environments, I can do the same demo, at CES in the automotive West, the new West Hall, where it's banging loud with music and people talking. And it still works just like this because again, it has that ability to spot that wake word and then spot the command that comes along with it. Voice Genie, show the map. So it's super easy, very fast. This is all part of Truly Hands-Free, and this is the technology that Panasonic has used for development of the product that Andrew is going to show you now. So let me turn it back over to Andrew, and I'll stop sharing here.
All right. Let me now share. All right. So the problem I'm going to talk about right now, just to set the background just a little bit. Actually, now I can't see if I look silly on mine. Hopefully you can hear me. To set the background on this, we took a look at an industry-wide problem specifically around the ability to open and close either a tailgate, trunk, or other door within the vehicle that was using what are typically referred to as kick sensors. So this is where you swing your foot wildly under the back bumper of your car and pray, hope, swear, or otherwise engage, wanting that back tailgate to open. So, and I mentioned to my wife I was doing a webinar today, and she goes, "Oh, what it's about?" And I said, "It's about using something other than your foot to open the back tailgate." And she said, "Oh, thank you. I hate that. It never works." And that's not just a problem for her. If you look at the 2021 JD Power IQS survey, it was in the top 10. I think it was actually ranked 6 for trunk hatch tailgate touch-free sensor does not work consistently, or it's difficult to use. That's also been my experience. Either a missed detection, it isn't responsive, when you're holding a lot of bags or something that's the reason why you're not manually opening the tailgate, you get unbalanced because you're trying to hold all these things and swing your foot underneath the back. Also, the layout behind the bumper of where they're putting the sensor, a lot of the other challenges with packaging, it was really ripe for an alternative. to that particular implementation. So what we did is we came up with, we want to introduce something that we're calling a speech-powered open close, or, because we have a lot of engineers on the team, we call it Spock. And basically the way that this particular implementation works is as you walk to the vehicle detects the key fob just like it would if you were walking up with an automatic door open where the key fob can remain in your purse or pocket. That's kind of providing an additional authentication and an activation to start listening to a phrase. And as you walk up, just like you do with somebody in the driver's seat, when you have your hands full and you say to your spouse or friend, hey, could you open the trunk, pop the trunk, open the tailgate, whatever it might be. That's then heard by an exterior microphone, again, using Sensory's technology in it. That picks up the command, and then a message is sent to pop the trunk. Okay, so in general, that's the gist of what we implemented. Now, if you look at the alternatives that have been out there, of course, the kick sensor we described, there's been some other attempts at other unique ways, like a hover system where you hold your hand in front of something like a logo or badge, and that pops the trunk. Again, that becomes a little bit challenging when your hands are full. So again, using something simple, but something that can be used not only robust with this voice activated system. It's very easy. It's something you do already when you have somebody in the car that can pop the trunk. It's very robust, and we'll go into how we tested that a little bit. The installation is easy, and I do want to mention cost-wise, many people have asked why not put it in the head unit. And as I mentioned, we have a very dominant market share in those infotainment-based systems that for sure can run Sensory technology and do today. The issue is, as you start to fire up a 220K DMIPS processor every time you walk by with a key fob, wait for it to boot or wait for a subsystem on it to activate, and then use the microphone to then open the trunk. And then that's assuming you didn't just walk by and didn't need the trunk open and it's in your garage. There was a lot of reasons to make it a very low power, very high performant, fast booting solution that could really handle this particular use case and be incredibly cost effective. So where we want it easy to install, we want the cost to be comparative to some of these alternatives like the kick sensor. And then it does give some other value to the OEMs, the ability to advertise about this new feature that would be very technologically advanced and a problem area for many users right now. And also for added use cases, there's a potential, and it does depend on mic placement and other things. But we mentioned, we were talking about the emergency vehicle detection system. Those microphones are being placed outside of the vehicle for those reasons already, for emergency vehicle detection, especially in ADAS or autonomous applications. There's a variety of things you can use that microphone in this system for that could be multi-purposed, let's say. So this would be a dedicated ECU, very low cost, very high performance, but dedicated ECU with this voice control, external microphones to allow users to issue the voice commands, and then also an interior microphone that's used when, especially on a rear hatch, that it might, if you have it on the outside, it might put it on the opposite side of where you're at if you want to say stop, or if you want to tell it to close the tailgate. That allows you to have multiple mic placement and gives you some capability to use it. Again, it's activated once the key fob presence is detected. And then we've already tested it in a variety of different noise environments that I'll talk to in just a second as well. And the commands are understood up to 2 meters away. So, you don't have to swing your foot and then dodge out of the way if you did happen to get the tailgate to open, to be able to put the packages in your back or whatever you may be holding. It understands different commands and languages. And there is an opportunity to also use voice biometrics, whether with the key fob or maybe to remove the need to have the key fob for authentication. There are some trade-offs in that in terms of memory and some other cost trade-offs that go into the biometric integration and the training and others. But that is also an option for this particular system. So as I mentioned, from, again, not needing to go right behind the vehicle and swing your leg underneath it, you really have a large distance and a large swath across the back of the vehicle that you can activate that that sensor now. So what it gives you, full hands-free when your hands are full, improves the operation of the lift gate, and you can, by the way, stop it mid-open in many of the implementations we've shown off. So not only you can say open the tailgate, but you can say pause, stop, close the tailgate. And it's a very large improvement over the toe kick sensor. Low power consumption, even with the car off. So it is ran off a very, very low power micro. And the nice thing about working with Sensory, it can run in a very small footprint of CPU and memory. So that's why we chose them for this application. It's very responsive in terms of boot performance, basically like you would get for a backup camera or other things that has to be activated within that 1 or 2 seconds from key fob detection. So by the time you get close, it's already up and running. And then we have a lot of acoustic and technology expertise in both the microphone design, placement, ECU placement, and then the integration into the full system. All right. So rather than go into more detail on it, we do have a video that I'll turn it back over. I think Jeff or whoever is going to launch it, but we'll show you a quick video.
And I think Chris has the video.
Oh yeah, Chris has it.
Open lift gate. This vehicle uses 2 microphones. The first microphone is located on the outside of the tailgate, just above the license plate. This is used for when the tailgate is closed. The second microphone is located on the inside of the tailgate. This is used for when the tailgate is open. Both of these will take your voice and electronically send a signal to the voice recognition system inside the box. This is used to change the state or position of the tailgate depending on your command. Close lift gate.
All right, yeah, simple and easy. So now we also, of course, have worked with Sensory on a lot of the infotainment things like keyword spotters, the enhanced Siri speech solution that uses it as a keyword, variety of other implementations. But I thought this one was a great one to talk about, a unique way to use it. So thanks.
It's awesome. Thanks, Andrew, for sharing the video. My daughter's car, if the key fob's in your pocket and you stand back by the trunk, it will start beeping, and after 3 seconds, it will open whether you want to or not, which is a horrible design. My wife's car, she's got one where if you put your hand over the logo for 3 seconds, then it will open. But that 3 seconds when you're standing out in the rain or just standing there in general feels like 300 seconds.
Mm-hmm.
And again, so we just don't use it because it's just not useful. And so the beauty of the design that you guys have come up with is it's the most natural. I love it. You walk up, you just say open the hatch, and it just starts opening. And again, the key fob is still the security device. And I've had people ask me about that. Well, does that mean anybody can come up to your car and just say it? No. You still have to have the key fob. So I think your guys' design of it is spectacular. It's a great use of the technology. So thank you for being such a great partner.
And I should say, a lot of people ask about the environments, and I think working with your team, we've tested it in calm, quiet parking lots, with reverberant parking garages, loud and busy parking lots, rainy, windy, all kinds of weather conditions, and it still has a much better rate of acceptance and working than the toe kick sensor does. So any of those other ones, even in all those conditions we tested it, it had a much higher rate.
That's awesome. That's great.
Hey, Jeff and Andrew, we've got one question from the audience that I think you might want to address right here. So thank you for the question. It says, what security features do you employ to prevent someone from unauthorized access to the voice-activated trunk? Is it just keyword spotting or individual voice recognition?
Well, again, I do want to make sure it's highlighted what we were just talking about using the key fob for second identity of somebody authorized to get in the vehicle. It's just like if you walked up with your key fob and you were going to your vehicle and somebody kicked under your car with the toe kick sensor at the same time as you had your key fob, there would be something when you unlock a door that somebody else could open it. So that is possible. Now, we have worked with Sensory to implement voice biometrics. It just requires some training and some other, from a memory and footprint, there are some trade-offs in that. But you could use voice biometrics to even up the level of security. And Sensory has a great voice biometric solution that we've been playing with as well. But I think for the first implementation is for a toe kick sensor replacement, we wanted it to be a similar level of security to also drive down cost and make it that we could fit the cost of this solution into the same kind of price point that an OEM would expect for a toe kick sensor. So it's a natural replacement in those high volumes of areas that consumers have problems with. And then from there, we can add on a lot of other security mechanisms if it's so desired. But voice biometrics is one. Sometimes we think about that as a way to remove the key fob requirement rather than using it for additional authentication. That you could use your own voice and recognize it to know that you're authorized to open the tailgate. But for now, that key fob becomes your authentication.
Yeah, exactly. The key fob is still the key. It just means that instead of, and as you said, Andrew, if somebody had the key fob and they kicked under it and they had the kick sensor, it would still open. And so it's still the key fob is the key. But as Andrew said, we do have voice biometrics that can also run deeply embedded. And so if we wanted to, I would say that the best approach would be to combine it with the key fob. I think it would make me nervous to not have a key fob and only go on voice, because if somebody had a really good recording of my voice, saying my voice password, they might be able to have access. But again, the key fob is the key. Great question.
Yeah, and so there's another question coming in here on the same topic. So let's keep going while we're on a roll. One is asking about wind noise. You guys spoke about noise, background noise in general, but specifically with this use case, wind seems likely. So are there specific design features you've used to minimize interference from wind noise?
Yeah, great question. So that was one of the big things we wanted to study, and we've been working with Sensory for quite a while on this. So from microphone placement and design, but also to giving recordings of different environments, including wind, and having Sensory work with us to train the algorithms and apply some techniques we have to remove it. We really see still, even in high wind conditions, an acceptance rate that's much better than a toe kick sensor. So I guess the point is, even in the worst rain, wind, hail, snow conditions, we're seeing a better acceptance rate than we're seeing with almost any other way to hands-free open a vehicle door.
Okay, and while we're on a roll with questions, if it's okay, let's take another one. So this person says, can the voice commands be customized for some particular people only? And I think what that question is about, Jeff and Andrew, is maybe, do the particular voice commands apply to everyone that might use the car, or are they specific to an individual user, individual versus, general commands? Does that make sense?
Yeah. I
was just going to say the voice biometrics, I'll flip it over to you, but that definitely could be trained to work for just one user on their voice biometrics. So it really triggers based only on their voice. So that is one thing. And sorry, I should mention on the wind and the external environment stage, if you're an OEM or this is a solution you're looking at, we could absolutely, there'll be a link at the end. We could have a meeting that we can go through the specific benchmarking we used to analyze the success rate of this particular application. We've got a ton of data we could go through and let the engineering teams work with you to understand it. But sorry.
Yeah. Yeah, thanks for that, Andrew. The demo that I showed using Voice Hub is what we call fixed wake word or commands where there's no enrollment, there's no training at all. Those are designed to work with everybody. And so the solution that we have right now with Panasonic really is anybody can use it. There's no enrollment, there's no training, and there's definitely an advantage to that. As soon as you require people to go through some training process, that can be scary to some people. And so the easiest solution is just fixed wake word, open commands, speaker independent, independent of the speaker. But we also support speaker dependent and enrolled wake words and commands where you could say, so I could enroll and my wife could enroll as an example. And so when I say open the hatch, it says, not only did I hear open the hatch, but that was Jeff saying open the hatch. And so it could be a signal to the rest of the systems in the car saying, oh, okay, Jeff just opened the hatch. So let's set up the temperature and the seat and the blah, blah, blah to Jeff as well. So there's definitely some interesting things that we could do there as well.
Yep.
Okay, and we have another question. So this person says that one of their favorite features of Sensory Truly Hands-Free is the ability to actually create custom work words commands on the device. Is this being considered or is it too complex for consumers? Does that make sense, Jeff?
Wake words and commands on device in the car. So I
think he means the ability where you can say it so many times yourself and that creates that particular wake word.
Yeah. So that would be our user-defined wake word or user-defined commands. It's definitely possible, but that's not been developed for this solution. This solution again is let's keep it easy, let's keep it low cost, and speaker independent is definitely the way to do that.
Okay, great. Well, it's fun that we have fans that are looking for particular favorite features to come out. So that's great. So we have hit all the questions in the queue right now. So if you guys have more slides or questions, we can go back to that.
Yeah, I know. Yeah. You could imagine, Chris, somebody wants theirs to be like, hey, Kit, open the trunk or something like that.
Exactly. Yeah, with a few more minutes, I wanted to introduce our in-car solution as well. This runs entirely in vehicle. And basically, as I said earlier, we take our custom wake word. So we've got that going on. Then we have our continuous large vocabulary speech to text. So this is full on open speech to text. Then a natural language understanding for command and control. We can combine it with the voice ID. We can throw in the facial analytics if we want to, the emergency vehicle. So it is a complete solution. And what I wanted to really focus on today is more the speech side of it. So the person comes up, they're in the car, they say, hey, Panasonic. So that's our wake word. It's running ultra low power. It's running on DSPs or other low power devices. Then we've got our acoustic model that basically understands the language, and we support today about 40 different languages, as well as an automotive language model that understands the words, the vocabulary that's within that automotive demand. So how far can I drive without refueling? That's the question. But again, it's natural. It's speech to text, so literally I can say anything I want to. Then we've got an NLU model that is basically saying, well, what's the intent in the entity? Oh, they're asking about the distance available from the gas that I have in the car right now. And then there's an action lookup table that basically we assign some software code that says, okay, this is what they want to do. They're check the gas level, what's the miles per gallon that I'm getting, and then respond. And then the spawn can be speech or can be display. You have 120 miles remaining. With 4 gallons of gas or whatever that happens to be. So, kind of going through the whole process here. Wake word, say what I want to say, understand it in the car, and have an action that follows that. So why is in-car important? Right now there's solutions that are hybrid. Some of it's in the car and a lot of it's in the cloud. The problem with the cloud is connectivity and speed. There's many holes, even in populated areas. I'm amazed every time I'm in the Bay Area, how many times I can't even make a phone call, or where, you know, if I'm searching something online, it's really, really slow because there's just really limited connectivity. So even in you know, the Silicon Valley area, that's the case. So if you're out in the middle of nowhere and you're trying to access a digital manual, you're gonna have a problem if it's not running in the car. As I said earlier, cost. Anytime you go to the cloud, there's costs associated with that. So we can remove that cost. And then privacy. I like this report by Mozilla, their privacy report in 2023. All new cars today are privacy nightmares on wheels that collect huge amount of personal information. If you think about when you get in the car, if you're using the speech tech in the car, there's no kind of accept, or I'm accepting cookies, or I'm accepting that my speech can be. It's just assumed, and so you know these are issues that I think people are going to have challenges with that we can solve today. A lot of different languages I mentioned, and those that have signed up for the webinar, you'll get access to this. And so you don't have to, you know, memorize all these right now. But I wanted to show a quick demo of our automotive solution here. And let me get out of this here. So this is all running on my phone again, and I'm just screen sharing. So what you can see here, once this, okay, so I've got a lot of different languages that you can see here, and I'll stick with English. You notice there's an 8 by it. Well, that means that we've created a bunch of different model sizes. So here's one that has the automotive acoustic model, the language model, and the NLU. It's all combined together. It's 291 megabytes, which is really small, by the way. But I'm gonna, for the demonstration today, I'm gonna use our extra small one. It's only 59 megabytes. It has the acoustic model, the language model, and the NLU. It's all in there. So that's the one I'm going to be using. So let's see. Yeah, there we go. And so it's on and listening. Here's my wake word. So, and it gives me examples of things I can say. So I can say things like, voice genie, turn on the front seat warmers.
Turning on front seat warmers.
And so you can see the recognition of what I said. You can see the NLU here. And so this action lookup table is going to put out to the engineering team, hey, this is what was recognized. Go and do this. Voice genie, set the temperature to 68 degrees.
Setting temperature to 68.
It's great. You can see as I'm speaking, it's typing it out. And again, here's the NLU, or things that are more complex. Voice genie, turn on the cruise control and set the speed to 83 miles per hour.
Setting cruise control to 83 miles per hour.
So you'll notice that there's text that's black and there's text that's kind of the reddish color. Every single word we're assigning and providing to the developer a confidence score. And so we can use this, and obviously everything's been perfect, but you can see here that there was a slightly lower confidence here than the other. But we can do things like, voice genie, navigate to the nearest Home Depot.
Displaying directions to the nearest Home Depot.
Then it actually pops up, you know, okay, from my place to the nearest Home Depot as an example. Voice genie, navigate to the nearest charging station.
Displaying directions to the nearest charging station.
Again, here's all my charging stations. And we can do text messages as well. So we can say things like, voice genie, send a message to Todd, let him know that I'm running about 15 minutes late because I'm in this cool webinar right now, and I'll call him later today.
Sending message to Todd.
So here, everything I just said, it's full on speech to text. This is all running on a CPU, all running in the car, which is, I mean, really amazing. Things like, voice genie, dial 408-898-7671.
Dialing 408-898.
And I ripped through that pretty fast. Voice genie, dial 415-555-1238.
I'm sorry, I don't know how to do that.
I don't know why I didn't get that one, but you can see 415-555-1238. Totally recognized all those things. And then things like if I wanted to, you know, media control, voice genie, I want to listen to Rush Exit Stage Left on Spotify.
Now playing Spotify.
So I did everything I could to try and screw that one up with, and it still got it. So this is our complete in-car assistant. Everything's running in-car. It combines the wake word, the speech to text, the language model, the natural language understanding, so that again I don't have to go, you know, external to do all these things. That's it for my quick demo, and we're just about out of time. So Chris, back to you.
Great, thank you. Let's squeeze in one more question, Jeff, because we did have that come in while you were sharing. So can you tell us a little bit about the impact of this technology on safety? We've had a lot of good comments on convenience today, but one of the participants is asking, how does this impact safety?
Yeah, at least in the, I'll answer for the product that we were talking about, and you could probably answer from a different perspective from the sensory technologies. But on the speech powered open close, it still has all the safety mechanisms in the door itself that are already built in, that it knows to stop when it encounters an obstacle, and it has all those in there. And then we also have voice commands that can indicate to stop as the trunk is, or the lift gate's being opened, stop as it's being closed. So there's all the normal safety mechanisms that are built into the door automatically, plus the added ones that you can use by just using your voice to say stop. So if you think in the toe kick sensor, you really don't have any way to stop the door from opening outside of holding it real quick if it's going to slam into the back of your garage if you haven't opened it, or it has to have other safety mechanisms for doing that. With this, you could say stop, and it would stop in the position it's in. So, and we also take pains to make sure, of course, when the vehicle's on or in motion, it disables the interior mic from opening the door as you're driving. So all the things you need to do to make sure that the system is safe and reliable are built in. And actually, when the door is closed, we only listen for the outside mic. When it's open, then we listen for the inside mic. Things like that. I don't know if there's a different answer just in general on the sensory technology you just mentioned, but clearly not using your hands or taking your eyes off the road. But I'll let you talk about it, Jeff.
Yeah, I mean, that's it, Andrew. It's keeping focus on what you're supposed to be doing, which is driving, and not kind of fumbling around and looking for, wait, I got to pick up my phone to answer a call, or when a screen pops up and you want to dismiss it. Doing all that by voice is way better than either touching the screen or using a joystick. Another demo we have is, what's the flashy icon thing on my dashboard mean? And we can recognize that, and it automatically pulls up the user's manual for whatever that area is, rather than hey, somebody grab this out of the glove box while I'm driving to try and figure out what do these things mean. Voice just allows me to keep my hands on the wheel and the eyes on the road.
Great. And we're about to wrap, but we do have one buzzer beater of a good question here. Does the on-device speech to text get close to the accuracy that is seen from the cloud?
Yeah, that's a great question. We're actually outperforming some of the cloud solutions today that are out there, which is awesome. So we've done some comparisons with companies like, everyone's excited about OpenAI and Whisper because of ChatGPT, and the LLMs are really cool, and we have integrated. I don't have time now, but we've got a demo for those that are interested. Let me know. I've got a really cool demo that integrates with the LLM, and but because we have access to testing and comparing those, we are outperforming them even with running this on device as opposed to cloud. Our word error rates are in the 5% and 6%, which is typically around what Google's getting.
That's great. That's perfect. So thank you, gentlemen. I think that was very informative. We're just ending right on time here, so folks have a chance to get a beverage before their next meeting. I appreciate your time and appreciate everyone from the audience joining. We will be automatically sending everybody a recording to this, and there'll also be some contact information if you want to follow up with Sensory or you want to follow up with Panasonic Automotive. So thank you all and have a great Thursday. Thanks, everybody.